Hello everyone. In this lesson, I will complete solving the ministerial question of lesson 4.3, limits at infinity. We reach question number 32. Find the equation of the horizontal asymptote of the function f of x equal to 4x power 3 minus 2x power 2 over 1 minus 2x power 3. To find the equation of the horizontal asymptote, we find the limit of the function when x approach to positive or negative infinity. Limit for x power 3 minus 2x power 2 over 1 minus 2x power 3. Since the numerator and denominator have the same degree, therefore the result is the coefficient of the leading term in the numerator over the coefficient of the leading term in the denominator. 4 over negative 2 equal negative 2. The right choice is y equal negative 2. Choice D. Question number 33. Find the equation of the horizontal asymptote for the equation f of x equal negative 2 over x plus 2. Rewrite this function as negative 2 plus 2x over x, the common denominator x. Also, find the limit when x approach to positive or negative infinity for this function. And since the degree of the numerator and denominator are equal is 1, therefore the result is the coefficient of the leading term of the numerator over the coefficient of the leading term in the denominator. 2 over 1 equal 2. So y equal 2 is the equation of the horizontal asymptote for this function. Choice A. Question number 34. Find the equation of the horizontal asymptote for the function f of x equal 2 plus x over 1 minus x. The limit of this function when x approach to positive or negative infinity equal to 1 over negative 1, since the coefficient of x is 1 in the numerator and the coefficient of x in the denominator is negative 1, so the result is negative 1. Y equal negative 1 is the equation of the horizontal asymptote for this function. Choice A. Question number 35. The horizontal asymptote of which function is y equal 3? Let us check. This function has no horizontal asymptote since the limit when x approach to negative or positive infinity equal to infinity. Infinity square minus 9 is infinity. For this function, the degree of numerator and denominator are equal, so the horizontal asymptote is negative 1, y equal negative 1 over 1 equal negative 1. So it is not a 3, it is wrong. For the third function, the degree of numerator and denominator are equal, so the coefficient of the numerator of x is negative 6 over the coefficient of the leading term in the denominator is negative 2. Therefore, the answer is 3. It is the right choice. For this function, when x approach to negative or positive infinity, the answer is 0. Therefore, y is equals 0 is the horizontal asymptote for this function. Therefore, also this is wrong. Question number 36. Find the equation of the vertical and horizontal asymptote for the function f of x equal 2 plus x over 1 minus x. For the vertical asymptote, set the denominator equals 0. It is mean 1 minus x equals 0. Therefore, x equal 1 is vertical asymptote for this function. For horizontal asymptote, find the limit of the function when x approach to negative or positive infinity. Since the numerator and denominator has the same degree, the coefficient of x in the numerator is 1 and in the denominator is negative 1, so the result is negative 1. And the horizontal asymptote is y equal -1. Therefore, the right choice is y equal -1, x equal 1, choice C. Question number 37. Find the equation of horizontal asymptote for this function. Since the degree of numerator is 1 and denominator is 2 greater than the degree of numerator, therefore y equals 0, or the limit of the function when x approach to negative or positive infinity equals 0, therefore y equals 0 is the horizontal asymptote for this function. Choice A. Question number 38. Find the equation of horizontal asymptote for the function f of x equal 3 over x minus 5. F of x equal to 3 minus 5x over x. The degree of numerator and denominator are equal. Therefore, the coefficient of x in the numerator is -5 over the coefficient of x in the denominator 1. Therefore, the result is -5 is the equation of the horizontal asymptote. Choice A. Question number 39. Find the equation of the horizontal asymptote for the function f of x equal 3x minus 8 over 3x power 2 minus 1 minus 2. The degree of numerator 1 and denominator 2 is less than the denominator. Therefore, y equals 0 is the horizontal asymptote for this function, since the limit when x approaches to negative or positive infinity is 0. Therefore, the right choice is D. Question number 45. Find the equation of the horizontal asymptote for the function 5x power 3 minus 2x power 2 over x minus 2x power 3. The degree of numerator and denominator are equal. Therefore, the result of the limit when x approaches to negative or positive infinity is the coefficient of the leading term in the numerator 5 over the coefficient in the leading term in the denominator -2. Therefore, y equal -5 over 2 is the horizontal asymptote of this function. Question number 41. Find the equation of the horizontal asymptote for f of x equal square root x power 2 minus 4 over x. Find the limit when x approaches to positive infinity for this function. Therefore, factorize by x power 2, 1 minus 4 over x power 2 for numerator over x equal to limit x approach to positive infinity. Separate this square root by writing square root x power 2 times square root 1 minus 4 over x power 2 over x equal to limit x approach to positive infinity 4. Since x approach to positive infinity, therefore square root x power 2 equal to x times square root 1 minus 4 over x power 2 over x. Reduce x with x. Substitute every x with positive infinity. 4 over positive infinity square 0. Square root 1 minus 0 is 1. The result is 1. When x approaches to negative infinity, the limit will be square root x power 2 equal to -x times 1 minus 4 over x power 2 over x equal to reduce x with x, substitute every x with negative infinity. 4 over negative infinity square is 0. 1 minus 0 is 0. Square root 1 is 1. Therefore, -1 over 1 is the horizontal asymptote from this case. Therefore, y equal 1, y equal -1. The function has two horizontal asymptotes. One when x approaches to positive infinity, -1 when x approaches to negative infinity. Question number 42. Find the equation of the horizontal asymptote for the function f of x equal 2 e to the x plus 1 over 2 over e to the x minus 1. Find the limit of the function 2 e to the x plus 1 over e to the x minus 1 when x approaches to positive infinity equal to 2 times e to the infinity. E to the infinity is infinity times 2 infinity. Infinity plus 1 is infinity over e to the infinity. Infinity minus 1 is infinity. Since the result is infinity over infinity, we can use L'Hopital rule. Therefore, by L'Hopital rule, the limit will be limit x approach to positive infinity. Differentiate both numerator and denominator separately. The derivative of 2e to the x is 2e to the x. And derivative of 1 is 0 over derivative of e to the x is e to the x. Derivative of negative 1 is 0. Reduce e to the x with e to the x, then the limit will be x approach to positive infinity for 2 equal to. Therefore, from this case, we have y equal to the horizontal asymptote. Limit when x approach to negative infinity for this function 2e to the x plus 1 over e to the x minus 1 equal to 2 e to the negative infinity plus 1 over e to the negative infinity minus 1 equal to e to the negative infinity is 0. It is equal to 1 over e to the infinity. 1 over infinity equals 0. Therefore, 0 plus 1, it is equal to 1. And e to the negative infinity is also 0. 0 minus 1 is minus 1. The result from this case is y equal negative 1. Therefore, we have two horizontal asymptotes, y equal 2 and y equal negative 1. Choice A. Question number 43. Find the equation of the horizontal asymptote for this function. The degree of numerator and denominator are equal. Therefore, the result will be 2 over negative 4 equal to negative 1 over 2. Choice A. Question number 44. If f of x equal ax plus 1 over x plus b has vertical asymptote at x equal 1 and horizontal asymptote at y equal 2, find the value of a and b. Since the function has vertical asymptote at x equal 1, and if we set x plus b equals 0 to find the vertical asymptote, and x equal 1 is a vertical asymptote, we substitute every x with 1, then 1 plus b equals 0 and b equal to negative 1. And since the function has horizontal asymptote at y equal t and the degree of the numerator equal to the degree of the denominator, therefore, the horizontal asymptote of this function is a, the coefficient of the leading term in the numerator over the coefficient of the leading term on the denominator. And since the function has a horizontal asymptote at 2, therefore a over 1 equal to, that's mean a equal 2. Therefore, the right choice is b equal negative 1 and a equal 2. Question number 45. Which function has vertical asymptote at x equal 3 and vertical asymptote at x equal 3 and horizontal asymptote at y equal 3? This function has vertical asymptote at x equal 3 and horizontal asymptote. There is no horizontal asymptote since the degree of the numerator greater than the degree of the denominator. Therefore, this choice is wrong. For this function, the vertical asymptote is x equal 1. If we set x minus 1 equals 0, then x equal 1 is vertical asymptote, not x equal 3. Therefore, this choice also is wrong. For this function, the vertical asymptote is 3x minus x equals minus 6 equals 0, then 3x equals 6, then x equal to 6 over 3 equal 2, not 3. Therefore, also this choice is wrong. For the last function, the vertical asymptote, if we set the denominator 0, then the vertical asymptote is x equal 3. And the horizontal asymptote, if we take the limit when x approach to negative or positive infinity for this function, then the result of this term is 0, since 1 over infinity minus 3 or negative infinity minus 3 is 0, 1 over infinity 0, and the result is 3. Therefore, y equal 3 is horizontal asymptote. Therefore, the right choice is D. Question number 46. Which function has vertical asymptote at x equal 3 and vertical which function has a vertical asymptote at x equal 3 and horizontal asymptote at y equal 2. For this function, the vertical asymptote is x equal 3, and for the horizontal asymptote is neither, since the degree of numerator is greater than the degree of the denominator. Therefore, this choice is wrong. For the second function, the vertical asymptote is 2x minus 3 equals 0, 2x equal 3, x equal 3 over 2 is the vertical asymptote, not x equal 3. So this choice is also wrong. For the third function, 2x minus 6 equals 0, then 2x equals 6, then x equals 3 is the vertical asymptote. But the horizontal asymptote is y equal 1 over 2, since the degree of numerator and denominator are equal, and the coefficient of numerator is 1, and the coefficient of x in the denominator is 2. So this choice is also wrong. For the last choice, the vertical asymptote is 2x minus 6 equals 0, then tx equals 6, then x equals 3 is vertical asymptote for this function. And for the horizontal asymptote, if we take the limit to the function, when x approach to negative or positive infinity, this term is 0, since the degree of numerator is less than the degree of the denominator, and limit of any constant function is the constant. Therefore, y equal to is the horizontal asymptote, and the last function is the right choice. Question number 47. If f is continuous function such that limit f of x when x approach to positive infinity equal 5, find if possible limit f of x when x approach to negative infinity if the graph of the function f of x is symmetric with origin, since the function is odd. Therefore, the limit of the function when x approach to negative infinity is equal to negative 5. If the function is even, then the limit when x approach to negative infinity for f of x will be the same when x approach to positive infinity. Therefore, the right choice is A. Question number 48. If f is continuous function such that limit f of x when x approach to positive infinity is 3 equal 3, find if possible limit f of x when x approach to negative infinity if the graph of the function is symmetric with y-axis. Since the function is even, therefore the limit of f of x when x approach to positive infinity equal to the limit of f of x when x approach to negative infinity equal to 3. And the right choice is B. Question number 49. Which is true? Which function is true? Which limit is true? Limit x power 3 when x approach to negative infinity equal to positive infinity. It is wrong, since negative infinity to the power 3, the behavior is equal to negative infinity. So this choice is wrong. the second limit, limit x approach to positive infinity for 5 cosine x over x equal 5. So also this is wrong, since limit x approach to positive infinity approach to positive or negative infinity for cosine x over x by squeeze theorem is 0. Therefore 5 times 0 is 0, not 5. So this also is wrong. Limit sine x when x approach to positive infinity is 0. It is also wrong, since the limit of sine x oscillating between negative 1 and positive 1. Therefore, we have the right choice is the last one, since if we want to find the limit of this function when x approaches to negative infinity, then negative 2x over square root factorized by x power 2 for the two term under square root 1 plus 2 over x power 2 equal to limit negative 2x over square root x power 2 times square root 1 plus 2 over x power 2 equal to limit negative 2x over square root x power 2, since x approaches to negative infinity, equal to negative x times 1 plus 2 over x power 2. Reduce x with x. Substitute every x with negative infinity. 2 over negative infinity square, 0. Square root 1 plus 0 is 1. Negative 2 over negative 1 equal 2. Therefore, the answer is true. Question number 50. Which is true? Limit cosine x over x when x approaches to positive infinity is equal 1. It is wrong. It is 0 by squeeze theorem. We solved it before. Limit x approach to positive infinity for this function equal negative 1. Let us see. It will be a limit x approach to positive infinity for negative x over square root factorized by x power 2, 1 plus 2 over x power 2. We solved it already in the previous question, but instead of square root x power 2 equal to negative x, we said x. Let us see, equal to limit negative x over square root x power 2 times square root 1 plus 2 over x power 2 when x approaches to positive infinity equal to limit negative x over x square root 1 plus 2 over x power 2. Reduce x with x, substitute every x with infinity, 2 over infinity 0, 1 plus 0, 0, square root 1, 1, negative 1 over 1 equal negative 1. Therefore, it is true. For the third function, limit cosine x over square root x when x approaches to positive infinity equal 1, it is also wrong. By squeeze theorem, if the cosine x is less than or equal negative 1, greater than or equal 1, if we divide all sides by square root x and take the limit for all sides when x approaches to positive infinity, then the result is limit cosine x over square root x less than or equal limit 1 over square root x when x approaches to positive infinity. 1 over square root infinity equal to 1 over infinity. 1 over infinity is 0. Less than or equal our limit, less than or equal limit 1 over square root x is also 0. Since 1 over infinity is 0, therefore the result is 0, not 1. It is wrong choice. For the last function, if we find the limit of this function, we have limit factorized by x power 2 for the numerator 1 plus 1 over x over negative 2x equal to, since x approach to negative infinity, then square root x power 2 equal to negative x times 1 plus 1 over x over negative 2x. Reduce negative x with negative x. 1 over infinity is 0, square root 1 is 1. Then the answer is 1 over 2, not negative 1 over 2. The right choice is B. Question number 51. Find limit x approach to positive infinity for x plus square root x over 9 plus x. If we substitute this every x with infinity, infinity plus infinity, infinity over infinity, the result is infinity over infinity. Then we can use L'Hopital rule. The limit will be differentiate both numerator and denominator separately. The derivative of x is 1. Derivative of square root x is 1 over 2 square root x. Derivative of 9 is 0. Derivative of square root is 1 over 2 square root x equal to, find the common denominator for the two term in the numerator. 2 square root x plus 1 over 2 square root x over 1 over 2 square root x. Reduce 2 square root x with 2 square root x, then the result will be limit 2 square root x plus 1 when x approach to positive infinity. 2 times square root infinity, infinity, infinity plus 1, infinity. The result is positive infinity. Choice C.